Hello, very good evening everyone. Thanks for joining the December 2021 meetup. So before we start, here is the quick reminder on this event etiquette. So please mute yourself if you are not talking. Please feel free to ask your questions in the gather chat. I can help to direct the questions to the presenter by the end of the talk or during the talk as appropriate. As always, we are looking for speakers, so please feel free to reach out to me or Steve and we can work together to have that scheduled in the upcoming meetups. As always, thanks AWS and KangZheng for continuing to sponsor this meetup. If you are new to this event, you can continue to connect with this meetup community by two ways. Like say to find the details of the upcoming events, you can directly follow the updates in the meetup page, or you can join our Slack channel to continue to collaborate with this community. I hope everyone enjoyed the recent reinvent from AWS. So the announcement for today is do look out for the reinvent recap here in our meetup. We hope to have this scheduled in the upcoming meetup, so please do look out for it. So here is the agenda for event tonight. The first talk will be from Shardul on deep dive of EKS IAM best practices. The second talk will be from KangZheng on designing the event-driven microservices using the approach of event storming. And the third talk will be by myself. I'll talk about designing and hosting the sustainable cloud solutions. Without any further wait, over to you, Shardul.
When we are using EKS, how do we assign permissions, and what are the best practices? Because there are a lot of challenges in terms of giving the best practices in terms of EKS. So I'm going to deep dive on each and every aspect of it and cover the overall IAM permissions, the how we should do it, why we should do it, what are the different ways. I'm going to cover each and every aspect of it. So when it comes to EKS, the IAM permissions are, there are two types of IAM permissions. One is node IAM permissions, wherein you can attach an IAM permission to a node so that when your workload runs as a pod on that node, it has the permissions necessary to do its job. For example, let's say you are running an application which is communicated to S3. Now, when you attach these IAM permissions to the node, the pod automatically gets those permissions, and then the pod itself can do communicate with S3 and do what it's supposed to do. And apart from that, there's another thing that is called IAM permissions and RBAC. So that is where user comes in. So would a user be able to do perform an action in the cluster, and how does that work? So I'm going to cover the first part in this. I have a separate slide deck to cover the user IAM permissions. I'm going to share the blog that I've written on both of these for further reading later. So when it comes to node IAM permissions, right? So you can attach IAM permissions. So here I'm primarily talking about, since I want to cover from the basics. So I'm primarily talking about covering attaching IAM permissions using something called EKS CTL. So EKCTL is one of the tools based on the kubectl paradigm, wherein it allows you to actually manage the entire or bootstrap or delete the entire EKS cluster. It was created by another company, and AWS has taken it as de facto standard for maintaining and managing the EKS cluster. So how do you do that in an EKS cluster which you are using EKSCTL to bootstrap? You can attach the IAM permissions to a node group. So in EKS, it's called node group. Different. For example, GKE calls it as node pool. Everybody has a different term, but essentially it means the same thing. A group of nodes. So if you want to create a node in EKS using EKSCTL, then you will have to uh, you know uh, you know ex, uh, you have to define it as the name, and then you have to tell it like all the details, like what is what is the type and everything. And that's where you can define something called attach policy ARNs. It allows you to attach some policies to the node. Now, uh, there's a gotcha here. The gotcha is that if you do not define any policy, the node will come just fine. It will work just fine. But it will have very basic set of policies by default, and these policies: EKS worker node policy, EKS CNI policy, and EC2 container registry. So CNI policy is just to make sure the VPC CNI plugin, which is in charge of giving the IP addresses to your pods works fine. It has the proper permissions. Then there's EC2 container registry read only permission, which as you know that all the daemon sets and all the system level pods that are running under kube system, they themselves are running on ECS repository, ECS registry. So when they want to pull these when for running those pods, when on the node you want to pull those uh, images for these the system level pods, then you're going to need these read only permissions so that you can pull those images and then run it as a system level pod on the cluster. And then there's a worker node which has some variety of permission which is needed for the cluster to for the node to register itself with the cluster, so that EKS cluster itself knows that there's a node that is part of it, and the scheduler kube scheduler can talk to the kube proxy to kubelet to schedule some pods onto the node itself. Now the gotcha here is that when you assign those permissions using the attach policy errands, you have to define it manually here. These are mandatory. If you do not define that, you're you will see those nodes being not ready when you do that kube control get nodes into the cluster. So you have to define that. If you do not define attach policy errands altogether, then it's fine, it's going to take it by default. If you want to define any other policies, such as I took an example of an application which interacts with S3 that you want to run as a pod or deployment, right? So for that you can define it separately as here that it needs to communicate to S3, create a bucket or delete a bucket, or create or delete some objects. Apart from that, actually, you can also apart from specifying the individual permissions, IAM policies, you can actually attach the entire role as well to the node. So that node role has the IAM permissions attached, and the role itself is attached to the node, just like normally it works with EC2, right? So you attach a role, that's the best practice, and then with the role there are some STS credentials, and that's how the node is able to make the calls. So you can attach using an instance role as well, and you can define it using this. So if you create a role for EC2 instance, then you will have instance profile ARN, and the role ARN you have to define here. And the node group, all the nodes in that node group that will come up will have the access to the role and the permissions attached to that role as well. Now, there's a problem with defining these permissions this way. One of the examples that I love is let's say in the same cluster you're running on Jenkins, right? And you're doing a CI/CD with that. Now, when you run a CI/CD on your cluster, you're going to need a hell lot of permissions than S3 full access or maybe S3 read only, because you are going to deploy a cloud formation, you're going to deploy the entire Lambda stack, serverless stack. A lot of permission would be required. So that's where when you give these permissions, any pod that comes onto that node pool, right? Node in the node pool will essentially inherit all those permissions. So it's a bad practice to attach any of these permissions onto the node group, because essentially all of your application which only need X3 maybe read only or probably full access will have CloudFormation admin, logging admin, CloudWatch admin, all those sort of permissions available, which is which actually which violates the principle of least privilege. You should only give the permission which is needed for the pod, right? Not more than that, or definitely not less than that. So that is the problem with this approach. It violates the principle of least privilege. And so what is the solution for this? The solution for this is something called IAM role for service accounts. This IAM role service account Google came up with around 2 or 3 years back, and it actually works on a very known principle that I'm going to cover later. So there is a solution to this problem of whenever let's say you are running two applications, one only needs a three read only, and the Jenkins. I mean, by right, when you are attaching those permissions to your node pool, you are actually giving everything away to the pod which doesn't require it. In any case, because there are so many vulnerabilities going on, right? Such as Log4j and stuff. That pod gets compromised, you're done. Attacker will have all the permissions that it needs to like havoc in the AWS account. So it's called in short it's called IRSA. So everywhere I'm gonna call it as IRSA. It's much more convenient. IAM role for service accounts. So so service accounts actually are Kubernetes native way of giving permissions. So in Kubernetes, right, there's also a permission model there. There are so many objects, then you can define read, list, delete, watch. There are several verbs that you can define for each of them. So any user, any service account in the cluster will have some of these permissions. On based on that, it works. For example, if you are deploying an application using kube control or using helm, then that particular, the user that you're using it for should have the enough permissions to run those commands, run that, deploy those things into the cluster. So how do you do that? In for applications, actually we have to use something called service account. So service account is something you have to define in a deployment aspect, like service account name, and then you create a service account in that namespace, and it's namespace specific always. So it's Kubernetes native way of giving, providing the permissions, and then you can create a role, and then you have to create a role binding. So role will have all those, like let's say you want to create a role where us service account should only have access to read, to list the pods, not delete it, or just the watch the pods as well. So you will give those words in the role, and then you attach the role using role binding to the service account. And then when you attach that service account to a deployment, that pod will have access to the cluster, and then it can run like kube control get pods, kube control get pods, dash watch, all those commands. But it cannot do kube control read pods. The kube API server will not allow that. It will just reject that request. So that's how service account is used in Kubernetes. So IRSA works on the same principle. It allows you to attach service account IAM roles to the service account itself. So when you run your pod with those service account, it will have that access to the role. So what does it do? It uses a new API. So it's called assume role with web anti API. It uses this API to give permissions to sort of assume those permissions that is attached to that service account by the role. So internally, it works on the principle of open ID connect. And then how do you use an IRSA? So you have to in a EKS cluster, you actually have to enable the OIDC provider. When you enable that, you will have some sort of a URL that is for your OIDC provider, and then you don't have to do anything, but yeah, internally EKS control will take care of it. When you just have to set a flag in your the YAML manifest that you have created for your cluster bootstrapping. You just have to say IAM OIDC 2, and it's gonna do that. Now how do you use this IRSA? Then actually there are number of annotations. So EKS has a number of annotations that you can use to use this IRSA. One such annotation is eks.amazonaws.com/role-arn. So you can attach this annotation to the service account, and then set the value would be the ARN of the role that you want to attach to the service account. And then when you attach this service account to a pod will have all the IAM permissions, and it will be basically able to access the whatever you have defined as part of the role IAM permissions. So this is how it works. So you create a service account, then you give an annotation, and you say eks.amazonaws.com/role-arn and the IAM role ARN, and that's how your service account is attached to the role itself. So how does really this work? AWS actually does a lot of things behind the scenes, but good thing is something like this is actually visible. We can actually see how it works. So IRSA actually works on a Kubernetes concept called mutating admission webhook. So there are two types of admission webhook called validating admission webhook and mutating. So mutating admission webhook is that we can run a sort of service, and what happens is when you register it with the API server, that service will be, whenever a pod is created or anything, any object is created, that service would be able to intercept the request that is made, and then it can do any changes to that request. Let's say we want to ensure that in the cluster, every time someone creates a deployment and we want to add a particular label, let's say organization is equal to my organization, right? And maybe sometimes people are not doing it. So what we can do, we can write an admission webhook, mutating admission webhook, and we can check that. And if it doesn't exist in the deployment, we can add that. That's how actually this IRSA is also working. So if in your ETS cluster, you can run a command called kube control get mutating webhook configurations, and then you will see that there's a particular webhook that is running in the cluster, pod int webhook. So okay, this only runs when you have this OIDC enabled. So what this guy does, this guy is the one who actually binds your service account to the role. We are going to see what are the things that this pod int webhook is doing in the subsequent slides. So this pod int webhook actually, so whenever, let's say, we have created a service account which has this annotation, right, that we discussed about, and then we attach this service account to a deployment. So when the deployment, actually when you do a kube control apply on that deployment, pod int webhook is going to intercept that, and based on the configuration that you have added to yourself, in terms of annotations, it's going to add several variables. For example, AWS default region. There's the region where your cluster is, AWS region. Then role ARN, which you have attached as an annotation onto the service account, and one particular AWS identity token file. This is where your actual credentials reside. So when you run AWS, AWS S3LS, actually it's going to take the credentials from here. So AWS CLI identifies this variable called AWS Web Identity Token file, and it will take the credential from here, and it's going to make the request and get the response and show you all the S3 buckets in the cluster. So these are all the these environment variable that are added by this pod identity. Apart from this, it also adds something called projected volume. So it allows you to, because this secret token, right, it actually comes using a projected volume, and that projected volume in turn makes a call to STS Amazon.com, and we can it by default AWS sets, when we configure this IRSA, it sets the expiration of those credentials as 86 for 400 seconds, but we can update it. We're going to see there are a number of annotations that we can use to update these configurations as well. So projected volume is actually just like any other volume, but it just allows you to keep all the volumes in the same directory. That's the good part of projected volume. Yeah. So there are other supported annotations as well, such as EKS Amazon.com/audience, and then there's STS regional endpoints. So there is a case wherein you might want to use regional endpoints in STS, which doesn't have much impact, but yeah, there are cases where latency is of big paramount. So that's where if you can actually use STS regional endpoints to get those credentials faster, so you can use that. But there's a problem with the latest EKS pod int webhook, that this sometimes doesn't work onto the service account level. Then there's something called token expiration. This is how you can override the amount of time that you can actually set it to the maximum value that STS allows, and that way your tokens will not be refreshed for a very long time, right? Then there's a skip container. This is very useful when you have multiple containers, right? By default you should not have more than one container, but there are certain patterns like sidecar container or ambassador pattern, right? Sidecar pattern. So where you are running multiple containers within your main pod. So if you, let's say, you are running some sort of init container or any other container, you don't want to have those non variables and projected volumes added to those containers, then you can skip those containers using this particular annotation. They're very useful for let's say you are using Istio, then there'll be a sidecar container of Envoy proxy. Then you wouldn't want these sort of and non variables and predictive volumes to be available to that. So then you can use this. Okay, so I have written two blogs on these even more in depth than I showed just now, and so these are the links. I'm going to share these links in the chat as well for the further reading. Like, thank you. I guess I can take questions now.
All right, thanks, Shardul. Any questions for Shardul? Counting to three, one. All right. Okay. So I think there's a question from
Um,
Akar. Um,
okay,
so
Okar, I think we should start thinking about this at each and every skill, because if you're using an application in production, right, and you wouldn't want to, for example, your node would want separate sort of permissions, but your application may not want those permissions to be available, and then you should definitely always use this, and it is actually very handy. Once you use those, you just have to create roles separately, like you may be using CloudFormation or anything in a separate repo, and then all you have to do is to, you don't have to worry about that when a node pool comes in, whether it has permissions or not. Maybe if it doesn't have permission and the pod gets scheduled there, it will not work. So I think you should use it everywhere. And this is very useful for Fargate, because in Fargate, you cannot attach any permissions to the Fargate pods. So this is the only way of attaching permission to the Fargate pods.
any further questions for Shardul? Shardul, there's another question from Leo. So
Yes. So there's no service account role as such, really, Leo. So we are just so Kubernetes has internal concept of service account. We are just creating an AWS role and adding that AWS role as an annotation to a service account. That's it. There's no service account role sort of concept here. We're just binding these together to make it work. So let's say you want to run a Jenkins where you want to create deployment, delete deployments and stuff. So that's where, and in Jenkins, and then you also want to deploy CloudFormation and stuff. That's where the permission that you're going to assign to your service account to allow it to create, delete, or update deployments and CloudFormation. That's where this would be very handy. That one service account will have AWS permissions, and by the way of annotations, that pod INT webhook will take care of your IAM permissions as well. Cool.
all right then. Perhaps if there are no further questions, I think thanks Shardul. Thanks for all your effort and time. In delivering an awesome presentation today. Yeah. Um, I think now I can request KangZheng, to share his presentation. Perhaps KangZheng, you can come over. All right. Yes.
Okay, I'm gonna come out of the. Um,
Uh, awesome. Okay, we can hear you now. Yeah. Go ahead.
Can you all see my screen?
Can yes.
And can you all hear me?
Yes. All good. Yeah.
Hello? Yep,
Yes. We can hear you.
that's okay. Okay, now I'll start. Okay, and hello everyone, and thank you for taking time this evening to attend this workshop. And today we'll be going through event storming, a strategy for deconstructing monoliths into event-driven architectures. And my name is KangZheng, an associate consultant for Source Group. And this course is one of 40 over modules in SORT serverless adoption program, where we look at transforming organizations and empowering them to adopt the use of serverless. To help understand microservices and their their differences with monolithic architectures, we use an ice cream machine analogy. On the left, we have a monolithic ice cream machine, and all the functionality sits within that single machine. So if any part of the machine breaks, then the entire machine often becomes unusable. Requests made by users and any data that is sent to a broken machine are often lost, and users will need to try from the start again after this machine is fixed. On the right, we have the microservices approach. Here, each function is split out into its own mini machine, and there is an orchestration layer at the bottom that manages the flow of the request through the different steps. This approach means we can monitor how each mini machine performs, automatically retry on failures, or continue where we left off after an issue is fixed. So the request and any data is not lost. And while this shows the differences, it does not really show how we split the monolith machine on the left into the mini machines on the right. And that is what event storming is about. There are some common challenges organizations face when converting a monolith to a microservices design. First, broken integration. It's easy to miss integrations between microservices, and this might only be discovered later when conducting end-to-end testing, or even worse, by users after the service is live. Next, creating a distributed monolith. There is a risk, especially for application teams that are less experienced in microservices, of creating a distributed monolith instead of microservices. And this is an architecture that tries to create microservices, but they are still heavily dependent on each other and on shared code. And it also describes an architecture where the scope of each microservice is too large, so it behaves more like a mini monolith than a true event-driven microservices. And this negates the benefits of microservices, such as the flexibility and scalability. Another challenge is incomplete services. Given the complexity and the number of features in a typical monolith, it is easy to miss functionality buried within it. And often, this does not come to light until actual user tests are performed. Lastly, duplicated services. It is common to end up with more than one microservice performing the same or very similar task, especially if the development tasks are shared between multiple developers working in parallel. And to mitigate these challenges, it's important to use an effective approach to break down the monolith and establish clear requirements for the rebuild. Event storming was introduced by Alberto Bradolini in 2013 when he wrote the first article. It is a facilitated group modeling approach to domain-driven design, or DDD. And it offers an effective method for deconstructing and transforming monoliths. And this approach uses business models to guide the architecture design process. Typically, event storming is conducted in a workshop setting, which helps a group to explore and understand what are the usually complex business requirements. Event storming deconstructs a monolith by identifying the business events, the relationship between these events, their triggers, and how all these moving parts work together to provide the full solution. This session will go through a series of insights gathering, then discussion, to iteratively work through the monolith as it is understood by the different participants. The outcome of the session will be several sequences of events around which the microservice architecture can be designed. In this talk, we outline a particular and popular approach to event storming. But it's important to note that there is no fixed standard. A key point is really the knowledge sharing and discussion. We use the different components of event storming to provide a structure, but it is adaptable. In short, feel free to customize the approach we will be sharing to create one that best suit your needs. Event storming focuses on engaging domain experts within the project because no one single person could understand everything about a giant monolith. Ideally, we want to have a group size of between 6 to 8 people from different areas. A typical monolith would have undergone multiple iterations with different developers that come and go during the application lifecycle. Further, having individual and specialized teams handling the various aspects of a project, such as security, networking, operations, and development, is a common approach to segregating duties. With the many isolated components within a system, you can be sure that no single individual knows everything about a monolith. With the group of experts, they come together to understand the bigger picture. The application developers are important participants because they are the one who knows the processes the best. The developers can span across different areas of the project, such as having a developer from a checkout service and a developer that is managing the payment service. Solutions architects understand the larger technical picture and know what things to consider when migrating to cloud. And they also know what external services are involved in the entire process. The project managers and product owners have a good overview of the scope of the project, and they can help to ensure that the story that we want to create is complete. And lastly, we can have legal and compliance to help us understand the policies and restrictions that may need to be considered. And before we proceed with a step-by-step example, let's go through the components of event storming and how they interact with one another. For every application, we have entities. They are the things that interact with the application. In our example, at the top, we have systems. They can be third-party services that interact with your application. We also have actors who are the users of the applications. The actors and system produces commands or instructions to the application. In this example, the user submits an order for the system to perform certain action, such as updating a database. These commands result in a domain event being generated, such as user submits an order form. A domain event will result in artifacts being produced, which will be shown on a user interface like a web browser that is interacted by an actor to produce even more commands. A domain event can also trigger policies, such as when condition pass or fail. These policies can either generate more commands or interact with other external systems, such as a notification service to notify user of a failure. Let's go through each component in greater detail. Here, we will be using an e-commerce example to provide some context, and we will be focusing on the backend services. The first step to event storming is to identify the domain events. Here, we want all workshop participants to contribute what they think are the individual events involved in the application workflows. Domain events are written with verbs in the past tense and generally describe an action of some kind. For our example, we will be using an orange color for the domain events. The focus is to collect as many events as possible. Some chaos during this stage is fine as everyone is contributing their ideas, but we want to limit any analysis that will distract from the collection process. We will get to analyze, order, and remove duplicates in the later steps. We use an e-commerce mock project in our event storming session, and which is why the examples here include events such as order submitted, payment process, and order completed. And once we have our collection of domain events, the participants can sequence them to tell a story of workflows. They are sorted from left to right in chronological order, and we remove or merge any duplicate events. If needed, we clean up the terminology used within the application to ensure a consistent understanding across all participants. Alternate and parallel flows can be placed in a separate swim lane above or below the main flow. For this exercise, we will be focusing on a happy flow, where we have a successful flow of event from start to finish. And we will address error handling in a later step. During this step, there is a good chance that missing events will come to light, and we can add those to the board to complete the sequence. The result of this step should provide a structured overview of the entire application. Next, we identify the commands using the blue sticky note. These are the triggers responsible for creating each domain event. These are written with verbs in the present tense. For example, customer submit order. It can help to remember that commands are given by an entity, either an actor or a system, which we will cover next. In our example, we have the domain event payment information received, which was triggered by the command send payment information, which was likely a customer submitting credit card details. Later, in our architecture, command will usually help to define an API endpoint or microservice trigger. Let's digress briefly to look at a slightly technical architecture diagram showing that. So on the left, the customer submits their payment information to our API endpoint, which is the implementation of the domain event payment information received. The API then issues the command process payment to our integrated payment processor microservice. Our microservice, which is the implementation of payment process, issues the command notify fulfillment center to the event bridge service. And this service does exactly that, arriving at another microservice, our implementation of fulfillment center notified. Once the commands are added to the bot, we can then identify the entities responsible for giving those commands. Entities can be an actor, which is a human interacting with an application, such as a customer or an employee. Actors usually produce command by interacting with a user interface, such as clicking a button in a website. Here, we identify customers as an actor that is responsible for submitting an order and submitting the payment information. Entities can also be systems, such as cloud services or an external payment service that interacts with the process. System can produce commands through scheduled events, callbacks, or when certain actions or rules trigger an event. We have two systems here, a third-party payment provider for processing the credit card, and a cloud service for triggering next steps in the workflow. Actors are represented in yellow, while systems are in pink. Uniquely, entity sticky notes are attached to the command sticky notes, as in the example here. After we have a happy end-to-end workflow, we can then introduce policies. Policies are applied after a domain event, and we use rules to determine the next step in our workflow. So examples of rules that we can define includes performing validation on user input, making an if-else statement based on a particular variable, or taking actions depending on the previous event, whether it was processed successfully or not. And one aspect to note here is that we are not looking at the technical implementation. So we do not need to consider all the checks and validations that might be needed. So for example, when user input validation fails, we want to know what's the next step. But we don't need to know what's the required parameters, what are the values or formats that might have caused the failure. In our diagram on the right, we added a policy with a purple sticky note. The policy takes action depending on if the payment was successful or not. If it was, it then proceeds to fulfillment and shipping. And if it doesn't, then it will notify the customer. If we digress again to architecture, there are several ways to implement policies in our design. In this example, we are using the model schema feature in API Gateway to perform user input validation. And with model schemas, we can ensure required variables are present, the format of values, specific values, and many other structure and value-based validations. If the validation fails, then API Gateway will respond with an error directly to the user, avoiding the need to invoke a microservice. For data validation that requires interactions with databases, other services, or more complex algorithm, we can then use the Lambda microservice. In our architecture here, we are using a microservice to check available inventory, for example. Event Bridge is commonly used to distribute events to one or more consumers in serverless applications. And we can implement policies here with filter rules to decide which consumer should be notified of a particular event. So for example, a successful payment event will be routed to the inventory microservice, whereas a failed event will be routed to the notification microservice. In step 6, we then identify the artifacts and schemas that results from each domain event, and they are added with a green sticky note. Example of artifacts include media files and documents, while schemas define the content of a database record. Defining this helps to identify potentially sensitive information, such as personal or financial information, and we can implement appropriate safeguard in our architecture. And we can identify common data attributes between these domain events. This could indicate that they're operating in a similar area, which can similarly drive architectural decisions. And lastly, the resulting output can help us to determine the appropriate cloud service to use for storing the data. For example, artifacts would likely be in a service such as S3 or Glacier. Product inventory may be a good match for a database such as DynamoDB. Financial transaction data that requires a high level of integrity could be stored in the Quantum Ledger database. Other database options for specific types of schema, such as time stream, for data that is tightly bound to a particular date and time, or Neptune, commonly used for recommendations engines. And there can also be use cases where sensitive data such as credentials might need to be stored, and services such as secrets manager can be considered. For step 7, we aggregate the events by grouping all the sticky notes that we have accordingly using nouns, which define the things that the event operates on. And to put it simply, they are the things that your command are acting on and what your domain event are creating, reading, writing, and deleting. Some examples here are order, payment, and product. And aggregates are usually your business entities that are stored in a database. And lastly, we have a bounded context or the scope of the application. Here, we remove related events, we group related events together to give it a context. And through this step, we can help remove dependencies between these boundaries. These boundaries help to separate a business process into smaller subdomains. And later in the architecture, each boundary can be represented by one or more microservices. A bounded context may consist of more than one aggregate, which could span across multiple boundaries. And to avoid microservices being too large, keep the number of events within a single boundary to a minimum. For example, we have identified a total of 3 scopes for this within this application. We have the order creation at the start, followed by payment processing and inventory management. And once we have finished our event storming exercise, we can use the output from each step to design our event-driven microservice. Recall from the following slides that the bounded context can help to identify one or more microservices, and the policies define the business logic that we have in place. The command provides an indication of how we want to invoke our microservice, either through an API or a microservice trigger. Aggregates defines the database that we want to create for our database, and the outputs that we have list the data schema that we want. Lastly, system could highlight any external integration that the application may have. And based on what we have gathered in the earlier step, for this order creation microservice, we have a customer that interacts to submit an order. Here, we have an API gateway to handle the command issued by the user. Next, we have the submit order microservice. And here, we can include any business logic that we have identified in our policies earlier on. To the right, we have the order database, which will be derived from the order aggregate, and the data that we have identified forms the data schema of our database. And here are some key takeaways for event storming. First, it's an effective approach to help deconstruct a monolith into smaller representations of your service, or what we call a microservice. There is no fixed standard to event storming. The focus should be on knowledge sharing, and many organizations have created different variations of event storming to cater to their business needs. Event storming provides a clear overview of your processes, creating a common understanding amongst your stakeholder, and it can be an effective tool to identify problems and issues within your processes, such as bottlenecks and also opportunities that the organization can take advantage of. In the event of any dispute during the session, we aim not to go into to the technical detail or implementation, and instead we will use a red sticky note so that we can come back to it later. And just remember that event storming is not a technical deep dive. It is used to explore the domain events for your microservices. And when designing your microservice, remember that it's supposed to be tight in scope. If it feels too big, consider breaking it down further. And you can do so by having another event storming session in smaller application teams to further break down the domains that you have identified. And that brings us to the end. And if you have any questions, please feel free to reach out. And you can also check out more of our event storming in our more about event storming in our article in our source group blog. Yep, and if anyone have any questions, please feel free to ask. Yep. So how would a policy look like in Lambda? So it's mainly just your if else conditions. Say if you receive say if you have a payment microservice that receives a payment transaction, and you could say if the transaction is successful, then this is what it will do, and maybe if it's not successful, then it will trigger a notification service. So it's mainly an if else statement. Yep. And any other question? Yep. How can I handle long running processes? Say you need to call Stripe to process and wait for the promise. Okay, so for long running processes, if especially when we are using a microservices, what we would do is we can use policies that could schedule a future event. Say if you are using a if you are calling a long running service, you could call a checker function, say maybe 5 minutes down the road, to see if the payment has been to see if the service has been successfully processed or not. So that is one way we could use it. Use event storming to identify all these long running processes. And one good thing about doing this is we get to know exactly what are the services that are of concern that takes a long time to run, which could affect the runtime, the cost of your Lambda functions. And this could help us to better separate and decouple all these synchronous events and be able to better manage the cost of our serverless application. And from Leo, what is the relationship between event storming and decoupling? Is event storming a type of decoupling? Not really. So event storming is more of a strategy. How we want to. So the main thing for event storming is to break down a monolithic application like the ones we usually have at data centers or in virtual machines, and to try to break them down into smaller pieces so that we could incorporate them into smaller microservices. And the type of decoupling that we are looking at, it could be an event-driven architecture, but that will be another topic altogether. And for integrated third-party service, always look for using. Yep, correct. So Thomas has also replied. So if we are really have to look for a third-party services, we do try to look for async services so that we do not have to incur the cost while waiting for a reply from from the service. And any other questions? Yep, thank you. Regarding the slides, I'll check again and I'll get back to and if I'm sharing it, then I'll reach out to the organizers and he can share it with the participants. Yeah, but I'll need to do a check first. Yep. Mm-hmm. Mm. Okay, so usually for people to even conduct event storming, they would first need a facilitator who is who um who who knows about who is how this who understands event storming and is able to conduct the session. And usually there could event storming is conducted in a physical setting, so we just get people to join a 1 day workshop, and at the start we do some icebreaker so that we get people to really be feel more comfortable sharing ideas, and that's about it. And usually we need the facilitator is a very important person there who needs to know how to engage the participants to get more ideas out of them.
I see. Okay. Actually, maybe one follow-up question again, and more into getting the thought process and having the sense on how this workshop goes. I understand, this event storming is going to be depending on the volume of architecture or the extent of how the architecture is going to be. But in your experience, how many iterations do you think, as an average, of what is needed for this event storming?
Okay, so usually we will have one where people will come together to really get a bigger picture, and from there we really can start to identify what are some of the business domains and what are the scope for the microservices that we want to create. But there's no real fixed number how many iterations we need to go through to really break down into the single to a ideal size. It's really up to the organizations. But if we find that if you have a microservice, sorry, if you have a domain, a bounded context that has a lot of user stories, so we usually try to scope it to within 3 to 5 user stories. And if there's too many, then we could consider doing another round to see if we can further break it down. Yep, and I think Thomas also mentioned something in the chat. So when we do event storming, we go through a mock project with the participants to get them to familiarize with the process itself. And usually after that, they also will be able to gain some capability to run this workshop on their own.
Thanks. Awesome.
Yep.
Any further questions for KangZheng? I think all right then.
Yep.
Thanks, KangZheng,
All right,
for
thank you.
presenting an awesome talk. This evening. Yeah. Let me. I think I'll come to a podium now. So this is going. Just a quick check that you can, all you guys can hear me. Yeah. And let me share my screen. All right. Just a quick check again. If you can see my screen as well. Can you drop a quick chat? Is that all okay? Can you all see my screen? Awesome. Nice. Okay, good. Thank you very much. Let me get this started. So, I think the topic for the presentation today is sustainability in the cloud, and this is more of about how do we go about creating a sustainable design um, into the applications, or perhaps specifically into the architecture when it comes to our cloud hosting applications. We will see some of the design strategies which you can I'm sure you can find in many blogs where recently post this reinvent where AWS have also introduced a sustainability as a separate well architecture pillar, which I'm sure it will provide much more insights into how systematically we can construct our architecture. Yeah. So actually, there's a generally a common misconception we have today that by moving our workloads to cloud, we are meeting our sustainability objectives. Well, it is partially true from the perspective that it is indeed AWS infrastructure or any cloud service provider. Perhaps in AWS in specific, it is 3.6 times energy efficient than the median US enterprise data center, according to the research paper what I saw in the AWS blog. So, but from a customer itself, from a customer or from a tenant with a cloud service provider, it is just the beginning. As in, we are still responsible for sustainability in the cloud. Yeah. That said, sustainability is a shared responsibility. So it is a shared responsibility between us and the cloud service provider. Let's say in this talk, AWS is a cloud service provider, so it's between us and the AWS cloud service provider in general. So here, AWS owns the responsibility of ensuring the sustainability of the cloud. That is what goes in inside the data center. That includes the electricity supply, the building materials, the waste management, the cooling technologies, what we have, the water management, and the service what is getting created on the data center itself. And we as a customer, we are responsible for sustainability in the cloud, which is the solution what we are running on top of it. That includes our data storage, how and the code efficiency, our utilization of the resources, how are we deploying our platform deployments, and our software application design, and finally as well on the data design and the usage itself. Now, so as we are responsible for sustainability in the cloud, how do we practice the sustainability? Well, it's absolutely no rocket science. It's all boiling down to practicing more efficient architecture design and the implementation itself. So how can we approach sustainability in a very systematic way? Is by focusing on different layer of infrastructure what we would typically have for any of our cloud hosted applications, which is a network layer of the infrastructure, compute layer of the infrastructure, and the storage layer of the infrastructure. Now, how do we approach a sustainability at the network layer? Actually, when we make our application available to our customers, we all know that the packets that has to travel across the network will increase. So more distance the packet has to travel, and larger the size, larger the size of the data, the more resource consumption it is going to take. So what can we ensure to approach a sustainable design here? We can ensure our design that the network resource consumption it is not growing linearly as much as possible as we expand our customers. So what are the design strategies what we can follow to achieve the sustainability here? It is the first thing is about reducing the network travel per request, which is something what we just discussed. So what can we use? It is what sort of technology what we can use? It is basically using the content delivery network, following the design strategy of read local and write global sort of methodologies and edge-oriented services. So it is basically to reduce the data that's sent over the network and optimize the path that the packet has to take to travel. So, like a content delivery network itself, we can take advantage of the globally distributed point of presence to catch the static assets and deliver the contents closer from the region where the user is requesting for the content itself. And so sort of a design approaches like read local, write global itself. So let's say with our data, let's say if you're leveraging on a relational databases like an RDS and Aurora, so we can have a globally distributed read replicas across the different regions. And let's say if we are leveraging on the NoSQL sort of a databases, then of course a DynamoDB which comes with a global table. So with that sort of a methodology, with that sort of a design approaches, we effectively achieve a design strategy in mating the read local and the write global sort of write global sort of a design approach, and thereby effectively reducing our network consumption itself. And finally, basically, is to use the edge-oriented services. So edge-oriented services, now, say for example, with a CloudFront, as a content delivery network with AWS. So a Lambda at Edge, which can go hand in hand, where we can offload certain compute functionalities there at the distributed point of presence itself. So now even for the compute, it doesn't have to come back to the origin to execute the compute and execute the certain business logic. Whereas now if we offload that into the globally distributed point of presence, we are effectively meeting the specific request lifecycle there closer to the user itself. Now, moving on, second point is about reducing the size of the data transmitter. So on top of catching the static assets, what we can basically do, it's again is something what we typically follow, which is to deliver the compressed file to the user, and let the browser of the end user to decompress the files, which browser naturally does that. So second thing is about optimizing our APIs. It is by leveraging the right endpoints. Say example, if you're leveraging on AWS API gateway. So AWS API gateway comes with the edge, the regional, and the private. So edge and the regional are very specific for the public APIs. So let's say if your customers, if your APIs are being consumed by the customers, where the customers are itself globally distributed, then we can effectively make use of our edge endpoints to present back the content from the closest point of presence where the user is located itself. And again, this effectively reduces the si- this effectively reduces reduces the distance that the data has to take to travel to reach the end users itself. And finally, again, it's about enhancing the EC2 network performance, which is enabled by default for most of the instances, like for which is the jumbo frames itself. So we can pass in. The idea is basically we pass in more data in a single packet, and thereby reducing the overall processing overhead. So here, jumbo frames are the maximum permissible packet size that can travel across the components in the network travel between the components, in any between any network devices. So while we are certainly sure that the resources hosted inside the VPC does it does supports the jumbo frames. While we may not be sure, like for the resources outside of the VPC, it may not be possible. So effectively the idea is when we have a confidence there in our VPCs, by design it supports the jumbo frames, and where possible, if you are putting forward any vendor-based solutions to effectively use the jumbo frames, if that comes to the default MPU itself. So, I also understand, like, there is absolutely no one AWS architecture size that fits all. So you can consider these recommendations and evaluate as appropriate to your use case. So now moving on, like what we know certain these are the design methodologies what we can follow. Now, what can we look at it to understand how best are we doing for each of those aspects? It is now again by looking at the observability metrics, what we naturally have in the AWS CloudWatch and the different sources and the different sources of events what we can leverage on for each of the services itself. Say for the CloudFront, we can look at the cloud capture rate, and from an S3 we can look at the data transferred in and out of the bucket. And from an EC2 instance itself, we can look at the network packets in and the network packets out, what is going in and out of the EC2 instance. And finally, Trusted Advisor for our overall CloudFront content delivery optimization related techniques itself. So, second thing is about approaching the sustainability at the compute layer. So, approaching sustainability um, um, at the compute layer is about. So we know for sure, like compute layer is the foundation for any of our workloads. So it brings in the great potential for our optimization itself. So the core idea with the compute sustainability is to do more with the less resources. So what design strategies what we can follow, in meeting this design approach? Very first, it's about reducing the idle resources and maximizing the CPU utilization, or maximizing the resource utilization in general. So I happen to read that AWS blogs where there is a paper on energy proportional computing, which is from a IEEE, and it noted a finding that when a compute resource utilization falls below 70 to 80 percentage, the energy efficient of the compute resource quickly decreases. So basically, while keeping an average utilization between 70 to 80 percentage in an on-premise data center might be a bit risky, but of course, when it comes to a cloud, we can make no excuses about it. So technically, this is very much possible in cloud by making use of an auto-scaling sort of an features for our EC2 instances to increase the supply when we are breaching certain threshold. And second thing is about and second thing is about right sourcing the resources. So, well, most of our use cases, pretty much from the organization what I'm coming in, and based on my interactions with the other colleagues from the different organization itself. So most of our applications are majority, I would say, like vast majority of applications are general purpose. So what here, from a nature of a general purpose itself, we need a bustable capacity here and there, but not all the times. So what can we do? To what can we do to get to meet those bustable capacity is by leveraging on the T instance types. So the T instance type, which comes with the bustable performance, and which we can effectively make use of for our general purposes. If we for those applications which are profiled as in general purpose itself. So what can we look at from an observability perspective in terms of providing a right sizing recommendation for the EC2 resources. Of course, looking at a cost explorer sort of functionalities, it provides us a nice view in terms of the utilization across the different EC2 instances, and providing a right sizing recommendations, which we can use as a source, and which use as a source to propose an appropriate instance type accordingly. So again, finally, is about also leveraging on some of the processor-based innovations. In this case, improving the power efficiency with the Graviton 2-based instances. And third thing is about using a serverless and event-driven architecture. Actually, this can be a right fit for our asynchronous and event-driven workloads, where the resources are only created, say, example in specific to serverless, like a Lambda. Here, the resources are only created when in use, and when not in idle, the resources are not. Of course, it is the containers are not going to be provisioned. Of course, well, yes, there are certain containers when it comes to uh, when it comes to um, um, for which are kept there as and when we have a large volume of requests to in a warming state. But the core idea is basically with the serverless sort of a technology and with the event-driven effectively applying the event-driven architecture. So this can be a right fit for this can be a right fit where the resources are only created when in use and not in the idle time itself. So we can make a best use of it. So again, so far, basically, our architectural approaches are generally like to increase the supply. Say, like say for example, with the auto scaling group itself. So when we breach certain threshold, we increase the supply to meet the demand. So, but when it comes to actually, it also makes sense. It also makes sense from a perspective of sustainability that we can think otherwise. That is to meet the demand with the existing supply. So, in this case, of course, it may not be appropriate for all the architectures, but where where we rely on the stateless workloads, and perhaps if that can be interrupted, we can of course use of that spot based instances. It comes with a 90% cost savings compared to an on demand, but here we are making use of the resources which are left spare, and thereby effectively making a good progress with our sustainability on our cloud design itself. And finally, it's about applying jitter to our scheduled task. I think it might look silly, but technically this is the common human perception where we use zero as the start minute for any of our scheduled tasks. But with the approach on relying on shaping a demand with the existing supply, it makes sense to modify those minutes anytime, any random between 0 and 60. So in this case, we are effectively moving out of the vast majority of vast majority of schedule instances, and we can appropriately take use of the the remaining spare minutes, moving out from the majority, and to keep the start minute anytime between 0 to 2 and 58 to have a scheduled task getting scheduled with the spot instances itself. And um, what else? What can we look at when it comes to an observability to understand how best are we doing when it comes to the sustainability? It is again by leveraging on the CloudWatch metrics. So let's say with the EC2, we can look at the CPU utilization metrics of the total number of virtual CPUs, and from a ECS, and with the CPU utilization as a metric itself. Likewise, there are many other compute services what we can put on, but the core idea is basically to again narrowing back to CloudWatch metrics, which are CloudWatch metrics for those from an IaaS perspective to look at the resource consumption to understand how best are we doing when it comes to compute layer itself. So finally, moving on to the storage layer. So what approach can we follow when it comes to the storage layer itself? It is by us following and managing an effective data lifecycle with the different storage type itself. So what design strategies what we can follow in achieving a sustainability here? If from a storage itself, from a slow changing or an unchanging data by moving to a magnetic storage as opposed to a solid state memory, and perhaps we can effectively make use of the S3 lifecycle event configuration to archive the data or to delete the data or moving between different storage classes as and when is appropriate, depending on the time period or the duration, what you rationalize for your use case. And third point is about perhaps it is very normal that we may not we may be unaware of certain access pattern, especially in the very start of the project cycle. So very start of the application go live, or application go live per se. So in that event, we can basically make use of S3 intelligent tiering for our storage to let S3 decide to move between different storage classes based on our based on our data access pattern itself. The second thing is about leveraging on the columnar data format. So uh, a columnar data format like a Parquet, it uses 6 times less storage in S3 compared to the text formats. So it may not be appropriate for all the data types, but for the data types like a CSV and JSON, this can be our natural choice when it comes to our storage with our columnar data format itself. So we also improve the query performance by storing, by executing our query against the less volume of data what we um, um, uh, the less volume of data what it has to iterate and what we store with the columnar data format itself. With say for example with an ETL technologies like an Athena. So the another point is about reducing the unused storage resources. Again, these are all a very basic, very basic sanity when it comes to when it comes to a storage perspective. It is the simplest way is from an EBS itself, deleting the unattached volumes and using the data lifecycle managers to delete the snapshots, which can easily accumulate if you are losing a control over it. So effectively make use of the data lifecycle manager to delete the snapshots and the AMI automatically. And finally, identifying the underutilized volume and downsizing it itself. So when it comes to storage mechanisms like an FSX or a S3, of course we can avoid the duplicates of the data, which at scale it is very possible for many different use cases. So we can make use of a deduplication functionalities when it comes to the FSX file server, or with the find and matches transform, let's say with the data lake, from a data lake perspective with the lake formations in effect, in executing this ML rule, identifying the duplicate data and to get rid of it accordingly. So finally, for the logs, what we persist by default, CloudWatch logs, it does not, it stores the data indefinitely and making sure we are defining an appropriate retention period there in the CloudWatch logs, and thereby reducing the volume of logs what we store in the CloudWatch and making us very resource efficient when it comes to our storage of logs itself. And here are the list of metrics what we can make use of to understand how best are we doing from each of those areas, like an S3, EBS, Elastic File System, and FSX. So I think I'm, I'm almost done. So in this case, in summary, from a network perspective, reducing the size of the data transmitter and optimizing the path, the data has to travel to through the network to reach the end users, and from an compute perspective is through reducing the ideal resources and also thinking about shaping the demand with the existing supply by making use of the spot instances to effectively meet the sustainability at the compute layer. And third thing is about from the storage, making use of data lifecycles and the different storage tiers effectively when it comes to our data storage itself. And I think that's all I have for the presentation today. And if you may have any questions, please feel free. Yeah. Yes, there's a question from Leo. Sustainability in the cloud and new pillar. Yes, yes. So sustainability is now being proposed as a new pillar, and I think it's after the reinvent, it is now added as one of the pillar, part of the current Bella architecture framework. I'm not sure about the details. You have to take a look, but I believe it comes with a lot more prescriptive guidance when it comes to a cloud architecture design. Any other question, guys? Or did I answer your question, Leo? All right, then. Perhaps if you guys have no further questions, then we are concluding the meetup tonight. Um, Thank you, everyone. Thank you, everyone, for joining the meetup tonight. And perhaps we will be around if you would like to have a catch up, post this meetup itself. But other than that, thank you, everyone, for having your presence for the meetup tonight. And I hope the talks what you had in the meetup today is informative to each one of you.